Welcome to History Explained, where we illuminate the past to better understand our present. I'm your guide to your daily journey through the past to empower the future. Today is Tuesday, July 1st, 2025. As we do every Tuesday, we're exploring the life and legacy of an influential individual whose impact continues to resonate through time. Today, we turn our attention to Marie Curie, one of history's most remarkable scientists who broke barriers in both gender and scientific achievement. Born Maria Sklodowska in Poland in 1867, she became the first woman to win a Nobel Prize, the first person to win Nobel Prizes in two different sciences, and remains the only person to achieve this distinction. What makes Marie Curie particularly extraordinary is how she overcame tremendous obstacles as a woman in late 19th century science while making groundbreaking discoveries in radioactivity that revolutionized our understanding of matter and energy. Her work laid the foundation for modern atomic physics and nuclear medicine. So let's explore the remarkable life of Marie Curie, examining her formative years in occupied Poland, her scientific education and partnerships, her revolutionary discoveries, and her lasting impact on science and women's advancement. Marie Curie was born Maria Sklodowska on November 7, 1867, in Warsaw, then part of the Russian Empire following Poland's partition. Her father, Władysław Sklodowski, was a mathematics and physics teacher, while her mother, Bronislawa, operated a prestigious boarding school for girls until tuberculosis forced her retirement. The Sklodowski family faced significant hardships under Russian rule. Polish culture and language were suppressed, and Maria's father lost his savings through poor investments. Despite these challenges, both parents emphasized education and instilled in their children a love of learning and Polish patriotism. Tragedy struck early in Maria's life. Her eldest sister Zofia died of typhus in 1876, followed by her mother's death from tuberculosis in 1878. These losses devastated the 11-year-old Maria but also strengthened her determination to succeed and honor her family's educational values. Maria excelled academically, graduating from her gymnasium at age 15 with a gold medal. However, as a woman, she was barred from attending the University of Warsaw. This restriction forced her to seek alternative paths to higher education, demonstrating the gender barriers that would challenge her throughout her career. The solution came through the Floating University, an underground educational network that provided higher learning opportunities for Polish students. Maria attended these clandestine classes while working as a governess to support her family and save money for further education abroad. In 1891, at age 24, Maria finally traveled to Paris to attend the Sorbonne, where she enrolled as Marie, the French version of her name. She studied physics, chemistry, and mathematics while living in extremely modest conditions in a sixth-floor garret in the Latin Quarter. Marie's dedication to her studies was legendary. She often survived on bread, butter, and tea, sometimes fainting from hunger during lectures. Despite these hardships, she graduated first in her physics degree and second in mathematics, demonstrating her exceptional academic ability. Her scientific career began when she sought laboratory space for research on the magnetic properties of steel. This quest led her to Pierre Curie, an established physicist 8 years her senior who had made significant contributions to crystallography and magnetism. Pierre and Marie quickly discovered their shared passion for science and social justice. They married on July 26, 1895, beginning not only a romantic partnership but one of history's most productive scientific collaborations. Their honeymoon was a bicycle tour through the French countryside, reflecting their unconventional approach to life. Marie's groundbreaking research began with her doctoral thesis on the mysterious uranium rays, discovered by Henri Becquerel in 1896. She coined the term radioactivity to describe this phenomenon and systematically investigated which elements exhibited this property. Using an electrometer invented by Pierre and his brother Jacques, Marie made precise measurements of radioactive emissions. She discovered that radioactivity was an atomic property, not dependent on molecular structure, a revolutionary insight that challenged existing theories about atomic behavior. Marie's most significant discovery came when she identified that pitchblende, a uranium ore, was more radioactive than pure uranium. This suggested the presence of unknown radioactive elements. Despite skepticism from the scientific community, she pursued this hypothesis with determination. Working in a converted shed that served as their laboratory, Marie and Pierre began the arduous process of isolating these mysterious elements. The conditions were primitive, no proper ventilation, extreme temperatures, and basic equipment, but their dedication never wavered. In 1898, they announced the discovery of two new elements, polonium, named after Marie's homeland, and radium. However, the scientific community demanded proof in the form of pure samples and atomic weights, requiring years of backbreaking work processing tons of pitchblende residue. Marie personally stirred huge vats of boiling ore with an iron rod nearly as tall as herself, gradually isolating tiny amounts of radium chloride. The work was dangerous, though they didn't fully understand the health risks of radiation exposure at the time. In 1902, Marie successfully isolated 1/10 of a gram of pure radium and determined its atomic weight, providing the proof demanded by skeptics. This achievement validated her discoveries and established her as a leading scientist in her own right. The 1903 Nobel Prize in Physics, shared with Pierre and Henri Becquerel, recognized their work on radioactivity. Initially, Marie was omitted from the nomination, but Pierre insisted on her inclusion. She became the first woman to win a Nobel Prize, breaking a significant barrier in scientific recognition. Tragedy struck in 1906 when Pierre was killed in a traffic accident in Paris. Marie was devastated but determined to continue their work. The University of Paris offered her Pierre's chair, making her the first female professor in the institution's 650-year history. Marie continued her research while raising their two daughters, Irene and Eve. She established the Radium Institute in Paris, which became a leading center for nuclear physics and chemistry research. Her work during this period focused on defining the international standard for radium and developing its medical applications. In 1911, Marie won her second Nobel Prize, this time in chemistry for discovering radium and polonium. This unprecedented achievement made her the only person to win Nobel Prizes in two different sciences, a record that still stands today. During World War I, Marie recognized the potential of X-ray technology for battlefield medicine. She developed mobile X-ray units, nicknamed Petites Curies, and drove them to the front lines herself, helping to save countless lives by enabling battlefield surgery. Marie's contributions extended beyond research to science education and international cooperation. She traveled worldwide, lecturing and promoting scientific education, particularly for women. She also worked with the League of Nations on international scientific cooperation. Her legacy in advancing women in science cannot be overstated. Marie mentored numerous female scientists and advocated for women's education and professional opportunities. Her daughter Irene followed in her footsteps, winning the 1935 Nobel Prize in Chemistry with her husband Frédéric Joliot-Curie. Marie's health gradually deteriorated due to prolonged radiation exposure. She developed aplastic anemia, likely caused by her years of handling radioactive materials without proper protection. On July 4, 1934, she died at age 66, a victim of her groundbreaking research. The medical applications of her discoveries have saved millions of lives. Radioactive isotopes are now used routinely in cancer treatment, medical imaging, and diagnosis. Nuclear medicine, directly descended from her work, has revolutionized healthcare worldwide. Marie Curie's scientific methodology influenced generations of researchers. Her emphasis on precise measurement, systematic investigation, and theoretical understanding established standards that continue to guide scientific research today. Her life story has inspired countless women to pursue careers in science. Marie demonstrated that gender should not limit scientific achievement, though she faced discrimination throughout her career. Her example continues to encourage women facing similar barriers today. The element curium, discovered in 1944, was named in honor of Marie and Pierre Curie. This recognition reflects their lasting contribution to our understanding of atomic structure and nuclear physics. Modern safety protocols in laboratories handling radioactive materials exist because of lessons learned from the Curie's experiences. Their dedication to research, while admirable, highlighted the importance of understanding and protecting against radiation hazards. Marie Curie's legacy extends beyond science into popular culture and feminist history. She remains an icon of perseverance, intellectual achievement, and the fight for gender equality in professional fields. Her notebooks, still radioactive after more than a century, are preserved in lead-lined boxes at the Bibliothèque Nationale in Paris. These artifacts serve as tangible reminders of her groundbreaking work and its lasting impact on science. Marie Curie stands as one of history's greatest scientists, whose discoveries fundamentally changed our understanding of matter and energy. Her courage in challenging gender barriers while pursuing revolutionary research makes her an enduring symbol of scientific achievement and women's empowerment. Thank you for joining us for this exploration of Marie Curie's extraordinary life and lasting influence. Tomorrow, we'll be back with our World Events episode examining the Cuban Revolution and its impact on Cold War politics and Latin American history. If you enjoyed this journey through history, please like this video, subscribe to our channel, and hit the notification bell. What aspects of Marie Curie's life and achievements do you find most inspiring or relevant today? Let us know in the comments below. Until next time, I'm your guide for History Explained, where we believe that understanding yesterday is the key to navigating tomorrow.